All right, people. I believe everybody is doing great, nice, and absolutely fine. So, welcome to Unacademy NEET English. So, guys, let me know in the chats if everything is perfectly fine, if I am audible and visible properly. Please do let me know in the chats and smash the like button because liking this session is extremely mandatory and mark your attendance. And one more important thing, guys. Please send some hearts, send some fire emojis in the chats. Light the chats with the fire emojis. Everybody. Okay. Everyone means everyone. Okay. Let everybody join and we are starting the session. Let everybody come and we are starting the session. Okay. Yo, yo, yo. And how is it going? How's your preparation going, guys? Sir, extremely depressed. Okay. We're having anxiety issues. We're having depression problems. Please help us in that. Chill, 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 chill. Everything is gonna be okay. That is for sure. Okay. Now, my dear friends, in this particular case, when it comes to this particular session, okay, when it comes to this particular session, that is the top 50 concepts of physics. Guys, listen to me very, very, very carefully. I'll be talking about those concepts. I'll be talking about those concepts which has the highest probability. I would say not the highest. 100% question will be asked from these particular topics when it comes to the NEET 2025. Okay. Now, guys, how many sessions will you take, sir? How many sessions will you take when it comes to this particular series? We can take 2 to 3 sessions. Okay. This will be the first session. Apart from this, we can take 2 to 3 sessions because whatever the concepts I'll be discussing over here, I'll be starting from the scratch. Okay. Doesn't matter if you have studied that particular chapter, but I will be starting from the scratch. If you give me your 100% attention, you are going to understand each and every single thing. That is for sure. I give you the guarantee. Okay. So that's why it will require 2 to 3 sessions. I'll be showing you the concepts along with the problems. Okay. Both concepts as well as the problems as well as the previous year questions. Okay. Now, my dear friends, session duration is going to be 2 to 3 hours. So stick to this particular session till the end. Okay. Shall we start the session? I hope everybody has joined. Shall we start the session? I hope everybody has joined. Okay. Yes, that's great. That's great. And I hope you have liked this particular session. Now, guys, let's basically move on to the topic number 1, extremely important. That is logic gates. You can expect 1 or 2 questions from this particular topic. Okay. Extremely important. Now, guys, when it comes to the logic gates, sir, what does this logic gate, what does this gate actually mean? What does this gate actually mean? Let me just tell you over here. See. In this logic gate section, I will be showing you a device. Ignore this Boolean algebra. I will be showing you a device. We'll be given a device. Okay. And in that device, we'll be giving some input. This is one input. This is another input, A, B. And it will give us some output. Simple. Sir, I'm bringing a device. We are giving some input. It will give the output. That's it. That's it. So we call this device as a gate. Sir, which gate? After some time, I'll be showing you it has different gates, or, and, nor. Okay. Right now, gate means a device, an instrument in which we give input and it gives us output. What kind of input and output? Please wait for some time. Okay. Now, guys, this input, it is called the digital signal, or this output, it is also called the digital signal. This input can be off. Either it can be 0 or it can be 1. Sir, can I not give input 2, 3, 5, 7? Apart from that, we say no, the input is only going to be 0 and 1. Sir, what about output? We say output is also going to be 0 and 1. So when it comes to the logic gates or the Boolean algebra, we say here input and output will be in the form of 0 and 1 only. Okay. Whatever the gate you take, whatever the input you give over here, it should be in the form of 0 and 1 only. Either you say we call it 0 also, or some people also write it 0 volts. It's one and the same thing. 1 means 5 volts. Okay. This is the another name. Similarly, 0 also means low, also means off. Okay. 1 also means 5 volts. It also means high. It also means on. One and the same thing. Cool. Yes. Next. Like, you have studied algebra in your previous classes, okay? Sir, we have studied addition, multiplication, subtraction. Here. You have Boolean algebra, okay? Boolean algebra. Here also, you will be having the addition, multiplication, and you have the inverse. These are the three mathematical operations that you need to perform in the Boolean algebra. This is not the normal algebra that you have studied previously. This is the Boolean algebra, okay? And here you have to basically study what? Here you have to study, we say addition, multiplication, and inverse. Now guys see. As I told you, when it comes to the Boolean algebra, as I told you, when it comes to the logic gates, input and output will be in the form of 0 and 1. Okay? Let's suppose if I say, in case of addition, one input is 0, another is 0. 0 plus 0 is always 0. Low plus low is always low. Directly remember. 0 plus 1 is 1. Low plus high is high. 1 plus 1 is 1. Please remember this directly. Okay? 1 plus 1 is 1. Okay? High plus high is high. If I say a plus 0, sir, a plus 0 is a. Sir, previously you said input and output will be in the form of 0 and 1 only. Why are you saying a? If I am saying a plus 0, this a can either be 0 or it can be 1. Okay, apart from that, it cannot be anything else. So if I say a is equal to 1, let's keep a 1. So 1 plus 0 will come out to be 1. Let's keep a 0. If a is 0, 0 plus 0 will be equals to 0. So result is coming out to be 1 as well as 0. So let's keep it as a. So that's why we say a plus 0 is a. Because the result can be 0 as well as 1. Now, see. A plus 1. If I say, sir, a plus 1, a can be either 0 or it can be either 1. Let's keep it 1. 1 plus 1 is 1. Let's keep it 0. 0 plus 1 is again 1. So in both the cases, answer is 1. So we say final output is 1. So final output is 1. I hope this is clear. Okay. Now, let's move on to inverse. Inverse means just the opposite. If I say 1, what is the inverse of high? 1 is high. So obviously it is low. And how do you show inverse? Just put this bar. 1 bar is 0. 0 bar is 1. Inverse of 0 is 1. Similarly, if I say a bar, that means reverse of a. If I say a double bar, we say these two bars cancel each other. It will come out to be a only. Okay? It is like 1 bar, second bar. First bar, do the inverse. So 1 bar is 0. Again, do the bar. It will come out to be 1 again. So that's why 1 double bar is 1 only. I hope this is clear. This is clear. Now, 0 multiplied by 0. 0 into 0 is 0. 0 into 1 is 0. Low into 1 is low into high is low. 1 into 1 is 1. Okay. Or if you say a into 0 is 0. A into 1 is a. A into a bar is 0. Sir, please show us this a into a bar. Let me show you. A dot a bar. Guys, a can be either 0 or it can be either 1. Let's keep a as 1. Sir, 1. And then you have 1 multiplied by 1 bar. That is 0. If you keep 1 bar here, if you keep a as 1, so 1 bar, it will be equals to how much? It will be equals to how much? 1 into 1 bar, 1 into 0, it will come out to be 0. Okay. Now, if you keep a as 1, if you keep a as 0, so 0 bar, that is 1. 0 into 1, again 0. In both the cases, answer is 0. So that's why it is 0. Now, how many of you understood this? Please tell me in the chats. Everybody with the fire emojis. How many of you understood this particular table over here? Please let me know in the chats. Everyone means everyone. I would want you guys to give me the signal in the chats if you understood each and every single thing over here. Tell me, guys, quickly. With the fire emojis. Okay? That's great. That's great. That's great. That's great. Now. Let's move on to, I hope Boolean algebra is completely okay. Now, let's move on to the gates. Let's move on to the gates. Okay? Let's move on to the gates. Guys, take a look. When it comes to the gates, gate means a device in which we give input, it gives us output. Okay? Which one? Addition 1, addition 1. This one also is simple. This one also is simple. You can do it from your end only, na? Okay? Now guys, listen. When it comes to the fundamental gates, you have got NOT gate, you have got OR gate, you have got AND gate. Sir, what is the work of NOT gate? When it comes to the NOT gate, we say its work is to do the inverse. Okay? Its job is to do the inverse. Okay? OR gate, its job is to do the addition. AND gate, its job is to do the multiplication. I'll show you. Next, guys, see. Let's first talk about the NOT gate, fundamental gates. Okay? NOT gate. Sir, this is the symbol of NOT gate. Everybody remember this. Guys, you have the triangle shaped structure and you have this ball over here. What is the job of this NOT gate? Its job is to do inverse. Okay, its job is to do inverse. Whatever you give the input, it will do its inverse. Let's suppose A. What will be the output? A bar. That's it. If you give 0, it will do its inverse. That is 1. If you give 1, it will give 0. That's it. Now guys, see, let's make truth table. Sir, what's a truth table? Truth table means a relation between the input and output. What you are going to give the input, what you will get the output. That is the truth table. See, let's suppose if you are giving 0 as input, what is the output? Guys, here A is input, output is A bar. So 0, it will be 1. So 1, output will be 0 because 1 bar is 0. That's it. Next, electrical equivalent circuit of NOT gate. Electrical equivalent circuit of NOT gate. Sir, what is this? This is that circuit which exactly behaves like, NOT gate. Let me show you how. See guys. This is the key over here. This is the battery, okay? This is the key over here, switch. This is the bulb. Let me make the truth table over here. See guys, in this particular case, I am saying this is the key means switch and this is the bulb. Understand this very carefully. Let's suppose you are switching on, okay? You will keep this switch on, okay? You will connect the circuit over here. We say current will leave from the battery, okay? So current flows. Now, current has two paths over here. First will be through the bulb, okay? And second will be through the key. Which path current will prefer? Current always prefers that path in which there is less resistance. Here it has bulb has resistance. So through this path it has less resistance. So when key is on means 1, we say no current will flow through the bulb. Current will flow through like this, okay? Current always flow in a loop. So current prefers to flow through this loop. So we say bulb remains off. When key is off, okay, we say it is disconnected here. Then current has only one path to flow, that is through the bulb. So when this is off, this remains on. Don't you think that this truth table exactly matches with this truth table? That is the truth table of NOT gate. Yes. So can I say this exactly behaves like a NOT gate, this circuit. Is this clear? Please tell me in the chats. Is this clear? Please tell me in the chats. Is this clear? Please tell me in the chats. Everyone means everyone. I would want you guys to tell me in the chats if this is clear. That's great. Great. Now guys, you have got the next gate. Okay, let me first finish the gates, then we'll move on to the questions. You have got OR gate over here. Sir, what is the job of OR gate? We say its work is to do what? Addition. Okay. We'll give some inputs. It will give us the output. As I told you, whenever we have the gate, we give some inputs. It will perform the mathematical operation. It will give the output. Its job is to do the addition. This is the symbol. This is the symbol. Something like this. Okay. Now, if A and B is input, what will be the output in this particular case? That is Y is equal to A plus B. As simple as that. Now, guys, take a look. Let's make the truth table. Guys, this is A, B, and this is Y. Now, tell me one thing. Tell me one thing. Let's suppose if I'm giving A as 0, B as 0, this input as 0, B as 0. 0 plus 0 is 0. Output will be 0. If this is 1, this is 0. 1 plus 0 is 1. If this is 0, this is 1. 0 plus 1 is 1. 1 plus 1 is 1. Now I'll write a statement over here which will help us to solve the questions within a very less amount of time. Now, guys, see, in this particular case, we say, guys, output is low when both the inputs are low. I'll write over here, output is low when both the inputs are low. Okay. And output is high, 1, 1, 1. When any of the two inputs is high, here this is high, here this is high, here both are high. So we say output is high when any of the two inputs is high. I'll write over here. We say output is high when any of the two inputs are high. When any of the two inputs are high. Okay. Now. Listen to me very carefully. Electrical equivalent circuit for OR gate. You have to make that electrical equivalent circuit which exactly behaves like OR gate. Okay. Now, guys, listen to me very carefully. Here I have made a circuit. In this particular circuit, there's a bulb over here and there's a battery over here. And this is key 1. This is key 2. You have got the two keys over here. Okay. Now, guys, if I make its truth table, you have got key 1, key 2, and this is the bulb. Okay. Like input 1, input 2, and this is the output. In this particular case, I want you to understand one thing. What is that? If I say key 1, if I say this key 1, this is off. Let's suppose I'll keep this key 1 as off. And key 2 also as off. We say current will come. It cannot flow through this path. Because it is disconnected. So current will not reach the bulb. So bulb remains off. Okay. Now, if this is on, this is off. Current can flow through this path and bulb will glow, bulb remains on. Now, if this is off, this is on. Current can flow through this path and bulb remains on again. Now, if this is on as well as this is on, still current will flow through the bulb, bulb remains on. Now, in this particular case, don't you think that, guys, output is low when both the inputs are low. It exactly matches with this. Output is low when both the inputs are low. Okay. Output is high when any of the two inputs is high. Okay. Exactly. You can see matches with this one. So this is the electrical equivalent circuit of, we say, OR gate. Then you have AND gate. Okay. What is the job of AND gate? What is the work of AND gate? It performs the mathematical operation, that is multiplication. Okay. And when it comes to the symbol, this is the symbol. Don't get confused with the symbol of OR and AND. Okay. Okay. Is this clear till over here? Is this clear till over here? I'll be showing you some questions, okay, on this also. You don't have to worry about anything. You'll get the idea. How do we make the circuits, okay? chill. Okay. One of my friend is actually in the chat, Sandeep sir. Okay, he also teaches physics, amazing physics educator. Okay, he's my friend in the chats. How are you, sir? How is it going? Amazing physics educator. Okay, guys. Now, take a look, guys. When it comes to the AND gate, guys, take a look. This is the symbol, okay? Okay. And what is the job? If you give input A, B, what will be the output? A into B. Simply, its job is to multiply. Now, guys, if we make it truth table, input A, input B, output. Let's suppose you give 0 as A. This is 0. 0 into 0 is 0. Let's suppose you give this 0. 0 into 1 is 1. Sorry, 0 into 1 is 0. Let's suppose this 1 into 0. 1 into 0 is 0 because high into low is low. Now 1 into 1 is 1. Now guys, what statement can you make over here? See. We say output is low when any of the two inputs is low. When any of the two inputs is low. Here this is low, here this is low, here this is low. Okay? And output is high when both the inputs are high. This is the statement that you need to write over here. Please keep this in your mind. Okay? We say output is high when both the inputs are high. Output is low when any of the two inputs is low. Keep that thing in your mind. Now, electrical equivalent circuit of AND gate. Let's make it something like this. Let's make it truth table. Key 1, key 2, bulb. See guys, let's suppose I'll keep this off. Current will leave from the battery. Okay, it cannot reach the bulb, so bulb remains off. Okay, cool. Yes. Now, if this is on, this is off, current will flow, but it cannot flow further because here it is disconnected. So bulb remains off. No current will reach bulb, so bulb remains off. Now, if this is off, this is on, still bulb remains off. Now, if this is on, then only current will reach the bulb and bulb remains off. On. Now see, we say output is low when any of the two inputs is low. Okay? And output is high when both the inputs are high. It is exactly matching with this one. So this is what we call the AND gate. Please give me the signal in the chats with the fire emojis. How many of you understood this very properly? Is this crystalline clear? Please let me know in the chats. Everyone means everyone. Tell me guys quickly. That's great. And the amount of theory I am telling you, this is sufficient when it comes to your NEET exam, when it comes to a JEE exam. Okay? You would be able to solve all the questions. Okay. I can see a lot of hearts in the chats. Okay. Okay, that's great. Okay. Let's move on to the next one. Now guys, now you have the NOR gate. Guys, see, what is NOR? NOR is basically the combination of, we say NOT plus OR. We say when OR gate is combined with NOT gate. What is the work of OR? To do the addition. What is the work of NOT? To do the inverse. We say it forms NOR. Okay. Now, guys, this is OR gate, this is NOT gate. Let's suppose you are giving input A and B. What does this OR gate actually do? It will do the addition. We say A plus B. This will be A plus B. Now this A plus B will further go into what? NOT gate. What is the job of NOT gate? To do the inverse, put the bar. So you give the input A plus B. Output, final output will be Y is equal to A plus B bar. Y is equal to A plus B bar. Now we say its symbol, we make it something like this. This is a bit longer. We make it something like this. Guys, see? So this is OR, okay? And instead of this complete NOT, we'll make its ball only, okay? Keep the ball over here. This is the symbol of NOR gate. This is the symbol of NOR gate. And if this is input A, this is input B, what is the final output? Final output in this case is Y is equal to A plus B bar. That's it. That's it. Okay. Now, guys, let's move on to the truth table. Let's move on to the truth table. Guys, A, B, this is the final output NOR. Ignore this. This is the final output NOR. A0, B0. What is the final output? A plus B bar. So 0 plus 0 is 0. And 0 bar is 1. That's why final output is 1. Now, if this is 0, this is 1. 0 plus 1 is 1. And 1 bar is 0. Final output is 0. 1 plus 0 is 1. 1 bar is 0. 1 plus 1 is 1. 1 bar is 0. Now you can see. Now in this case, can you guys see? Guys. We say output is high when both the inputs are low. Output is high when both the inputs are low. Okay. And what is the next statement that I can use over here? Output is low when any of the two inputs is high. Output is low when any of the two inputs is high. Extremely important statements, okay? Now guys, electrical equivalent circuit of NOR gate. Electrical equivalent circuit of NOR gate. Now I want you to understand this. Guys, see. So this is the battery, this is the key 1, this is the key 1, this is the key 2 over here. Guys, see. Let's suppose current will leave from the battery, something like this. This is the bulb over here. Let's suppose you'll keep this bulb, you'll keep this off. We say current cannot flow through this path. Current cannot flow through this path. Current has to flow through the bulb. We say bulb remains on. Okay. Now guys, if this is off and this is on, we say current will prefer this particular path. Sir, why will current prefer this path? Because there is less current through this path. There is less resistance through this path. That's why current will prefer that path in which there is less resistance, not through the bulb. So no current will flow through the bulb. Bulb remains off. Okay. Now guys, one more thing. We say when this is on, we say in that case also no current flows through the bulb. Bulb remains off. Okay. And now let's keep this as off and this as on. Okay. So we say this is off, this is on. In that particular case, current will flow through this. No current will flow through the bulb. Bulb remains off. Now, don't you think in this particular case, guys, don't you think in this particular case, output is high when both the inputs are low? Output is high when both the inputs are low. Yes. We say output is low when any of the two inputs is high. Output is low when any of the two inputs is high. So this circuit exactly behaves like NOR gate. This circuit exactly behaves like NOR gate. Okay. Now you have got NAND gate. Final gate, and we are done with this. Now you have got NAND gate. Okay. Now guys, take a look. NAND gate. When it comes to the NAND gate, we say it is the combination of AND plus NOT. Okay. We say AND plus NOT makes NAND. This is the symbol of AND. This is the symbol of NOT. AND plus NOT is what we call the NAND. Now, how do we make it symbol? How do we make it symbol? Guys, make this as it is over here. Instead of this not, just make the ball over here. This is what we call the symbol of, NAND. Okay. Now, my dear friends, in this particular case, if we make it truth table, guys, see, what is the final output? Guys, understand one thing very carefully. If this is input A, this is input B, we say, what is the work of AND gate? Its work is to multiply. So A into B. Okay. Then when it further goes over here, when it further goes in this particular one, so we say its job is to put the bar A into B bar. This will be the final output. Okay. So what is the Boolean expression? Boolean expression means final output. That is AB bar. AB bar. Now let's make the truth table. 0 into 0. What is the final output? AB bar. So 0 into 0 is 0. Then 0 bar will be equals to 1. That is 1. 0 into 1. 0 into 1 is 0. 0 bar is equal to 1. 1 into 0 is 0. 0 bar is equal to 1. 1 into 1 is 1. 1 bar is equal to 0. This is the final output of NAND. Now, can you see in this particular case? Guys, we say output is low. Sorry, output is high. Output is high when any of the two inputs is low. When any of the two inputs is low. And output is low when both the inputs are high. Output is low when both the inputs are high. Okay. Now guys, let's make its electrical equivalent circuit. Okay, electrical equivalent circuit of and NAND gate. Guys, see, you have got over here, this is K1, this is K2, and this is bulb. Now you tell me one thing, guys. We say current will leave from here. Let's keep this as off. We say this is off. No current will flow through this path. Current has to flow through the bulb, so bulb remains on. Now, let's suppose this is on, this is off. If this is on and this is off, in that particular case, we say no current will no current will flow through this path because it is disconnected here. Current will flow through the bulb, so bulb remains on. Okay. Now, if this is on, this is off. So this is off, this is on. Again, bulb remains on because no current flows through this path. If we say this is on, then current will flow through this path only, okay? Not through the bulb. If this is on, this will remain off. Now, this truth table exactly matches with this. So we say this is the electrical equivalent circuit of NAND gate. Please tell me in the chats if this is crystalline clear. Everyone means everyone with the fire emojis. He seems like a very genuine teacher. I am a genuine teacher, bro. What are you saying, huh? Okay, that's great. That's great. One more important thing, guys. We say on 23rd March, Wasim sir will be launching the finest test series when it comes to the NEET 2025. Okay. I would want you guys to smash the like button over here after this session. Okay. This session is very much important. Okay. On 23rd March, 8 p.m. he'll be launching the test series, and this will be the best of the best test series when it comes to the NEET 2025. Do join this particular session. Extremely important for the NEET 2025 students. Okay. Okay. Now, Now, guys, one more important thing I would want you guys to remember. Is this enough for NEET? This is enough for JEE also. Now, guys, take a look. Now, guys, take a look. I say single input NAND, single input NOR. What does single input NAND and single input NOR actually mean? See, guys, this is the symbol of NAND gate. Okay. This is the symbol of NOR gate. Okay. Okay. When I say, guys, when I say single input, join this, join these two inputs. Now this becomes the single input. Let's suppose if you are giving A as input, that A will go in this also, that A will go in this also. Okay. What is going to be the final output? Final output is going to be A into A, then we say bar. Why? Because we say when it comes to the NAND gate, it multiplies the two inputs, then puts the bar. Now A into A bar, that will be how much? A into A bar will be A bar only. Okay. Put A is equal to 1. Okay. So 1 into 1 is 1. 1 bar is 0. Put A is equal to 0. 0 into 0 is 0. 0 bar is 1. Okay, so final output in this particular case, I'll be writing over here, that is going to be Y is equal to A bar. I would say, which is the output of NOT gate. Guys, directly, ignore what I said. If you ever see single input NAND, means it is a NOT. Single input NAND is NOT, and it will give the final output as A bar. And when it comes to the single input NOR, this is also equal to NOT gate. Single input NOR is also equal to NOT gate. Keep these two things exactly in your mind. Okay? Okay? No. NOR and NAND symbol are not same. See, here it is a straight line. Here it is curve. That's the difference. We say single input NAND is not, single input NOR is also not. Now, guys, let's move on to the questions. First one, NEET 2017. Now you would be able to solve these questions within a fraction of seconds. Take a look. Guys, the given electrical network is equivalent to, this is A and B. What is this? This is over here NOR gate. Okay. What is this? This is single input NOR, and which is equal to NOT. Single input NOR is NOT. And then further, this is what? This is NOT only. Now tell me, guys, A and B, what is the output of this? This will give the output as A plus B and then bar. Because what is the output of NOR gate? A plus B bar. Now, this A plus B bar goes into this NOT gate because this is NOT. So it will give the output of A plus B bar double bar. Whatever goes inside the NOT gate, it puts the bar. So this is the input of this NOT, it will put the bar. Now these two bars will cancel. Now this A plus B will go in this NOT. So final output is going to be A plus B bar. Why? Because this will again put the bar. So A plus B bar is the final output. So which is the output of NOT gate? So it is a NOT gate. Option C, why are you saying A? Option C is the correct option. Guys, this is NOR. Look at me. Again, I'll show you. A plus B. What is the output of NOR? A plus B bar. Now this is not, don't say this is nor, this is not, because that is single input. In two inputs are joined. So if this is not and this is input, not puts the bar on its input. So it will be A plus B bar, one more bar. This one more bar is due to this not. Now, two bars cancel each other. Now this is A plus B only. Now A plus B goes in this not. So final output will be A plus B bar. Final output will be A plus B bar. Okay? Okay, yes. It is a NOR. Yes, it is a NOR. Sorry. Because final output will be A plus B bar. Okay, that is a NOR. Yes. Is this clear? Is this clear? Yes. NOR. B. Is this clear? Because A plus B bar, if you check the output of NOR gate, that is A plus B bar. Is this clear? Now guys, tell me about this one. 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 Session notes I'll be sharing in this. Session notes I'll be sharing in this. Okay. In the Telegram channel, I'll be sharing the Telegram channel. Just a second. Now guys, tell me. We say this is the electrical equivalent circuit. Now I would want you guys to focus exactly in this particular case. Guys, see. I'll make this circuit over here. Guys, see. This is the key. Okay. And this is the resistance you have. This is the bulb you have. This is one more resistance. And okay. This is over here. This is resistance R. This is bulb LED. This is resistance. And this is plus 6 volt. This is K1 and this is K2. Now guys, tell me one thing. In this particular case, I would want you guys to tell me one thing. Guys, you have to check. This is the electrical equivalent circuit of which gate? Do one thing. Make the truth table. How many keys are there? 2. We say, sir, K1, K2, and you have got bulb. K1, K2, and bulb. Now, guys, see. Always remember, current flows from higher potential to lower potential. It is grounded over here, so 0 volts. Now, see, current flows from plus 6 volts. Now, current will go something like this. Let's suppose if we keep this as on. Okay. And let's suppose if we keep this as off. So current will flow through K1, but it cannot flow through K2. So current cannot complete this loop over here. So current has to flow through the bulb. So bulb remains on. Now, if we keep this as off and this as on, this off, this on, still current cannot complete this path. Current has to flow through the bulb. Bulb remains on. Now, guys, we say if this is off, this is off. We say this is off and we say this is off. In that particular case, current cannot again flow through this path. Current has to flow through the bulb. So we say on. Now, if this is on, this is on. We say if K1 is on, K2 is on. Now current can complete through this path. Current will flow through this path because here there is less resistance. So current cannot enter the bulb. Bulb remains off. Now tell me one thing, guys. We say output is high. When any of the two inputs is low. Output is high when any of the two inputs is low. Output is high when any of the two inputs is low. Output is high when any of the two inputs is low. Okay, one more thing. We say output is low when both the inputs are high. Output is low when both the inputs are high. Don't you think it is a NAND gate? Don't you think it is a NAND gate? Which gate it is? Which gate it is? NAND gate. So NAND. That's why I told you those two statements are extremely important. Okay, next one. NEET 2019. I would want you guys to solve this. I need to see how many of you can solve this question. See guys, I'll make it over here. This is 0 volts. This is plus 6 volts. This is K1, this is K2, and this is bulb. Now, make the truth table. Then only we can check. This is K1, this is K2, and this is bulb. This is K1, K2, and this is bulb. K1, K2, and bulb. Okay, I have made it over here. Now guys, let's keep K1 on and K2 off. If this is on, this is off. Guys, current will flow, something like this, and will reach over here. No current flows through the bulb, so bulb remains off. Okay. Now, if this is off, this is on. Let's keep this as off, this on. In that case also, no current flows through the bulb, bulb remains off. Okay. Let's do one thing. This on. Let's keep both on. On, again, bulb remains off. No current flows through the bulb. Now, if this is off, disconnected, current has to flow through the bulb. Current will flow through this path. So we say if this is off, bulb remains on. Now, output is low when any of the two inputs is high. This is NOR. Is this NOR? Please tell me in the chats if this is crystal and clear. I would want you guys to tell me in the chats if this is crystal and clear. Guys, tell me. Everyone means everyone. And smash the like button if you have not liked the session yet. Guys, marking the attendance is extremely mandatory. Guys, see, NEET 2016, JEE Mains 2012. Tell me, for the following circuit to give output as 1, the correct choice of inputs is. You guys are supposed to say output must be 1. What should you give the input? What should be the correct choice of inputs? Guys, let's give this 1, 0, 0. A is 1, B is 0, C is 0. And this gate is OR, this is AND. Now tell me, what is the work of OR? To do the addition. So 1 plus 0 is 1. 1 plus 0 is 1. This will do the addition. Now this is 0, 0 will go directly. What is the job of AND? To multiply. 1 into 0 is 0. So final output is 0. So means this is wrong. Let's check for option C. See guys. So this is 1, this is 0, this is 1. Now 1 plus 0 is 1. Now this 1 will go directly as it is. Now this, what is the job of AND? To multiply. So 1 into 1 is 1. So final output is 1. So correct choice of inputs must be this. Then only final output will come out to be 1. This was the question asked in mains as well as in NEET. Next. NEET 2018. What about this one? In the combination of the following gates, the output Y can be written in terms of A and B as. Guys, see. This is not. This is also not. This is and. This is and here this is or. Now see, this A will go directly as it is. This B goes here. This is not. If B is the input of not, it will do the inverse. So this will be B bar. Now what is the job of AND? To multiply. So A into B bar. This will do the output of this will be A into B bar. Because its job is to multiply. A into B bar will be the output. Now this A as it is will go here. Not is present here. So it will do the inverse. It will do the inverse. So here it is A bar. Now this B will directly go here. It is B. What is the job of this AND? To multiply. So it will do A bar into B. Now, this will go as input. This will go as input in this OR. Now, what will be the final output? So its job is to do the addition of its inputs. So that will be AB bar plus we say A bar B. This is going to be the final output. This is going to be the final output. Is this clear? Please tell me in the chats. Is this clear? Please tell me in the chats. XOR, okay, XNOR, those are not present in your syllabus when it comes to the 2025. If you check the syllabus, these are the only gates that you have to study. Okay? Keep that thing in your mind. Now, guys, what is the output Y in the following circuit? What is the output Y in the following circuit when all the three inputs A, B, C are first 0 and then 1? See, what does it say? It says that if we keep the input as first 0 means 0, 0, 0. Then we give the input as 1, 1, 1. What will be the output? Let's first give the input as 0, 0, 0. What is this? This is AND. What is this? This is NAND. Okay, because ball is present over here. That's why this is NAND. Now, what is the work of AND? Its work is to multiply. So 0 into 0. This is these are the two inputs of AND. So its output will be 0. Now this 0 will go over here. Now what is the work of NAND? To multiply and then put the bar. A, B bar is the output. Now 0 into 0 is 0. 0 bar is 1. Output is going to be 1. So I'll write over here. If inputs are 0, then output is 1. Now tell me, guys, if I keep the inputs as 1, let me keep the inputs as 1. 1, 1, 1. 1 into 1 is 1. So here also 1. Now what is the work of this NAND? A into B bar. 1 into 1 is 1. 1 bar is 0. Final output will be 0. If inputs are 1, then output is 0. So final combination of output is going to be 1, 0. 1 and 0. Okay. I hope this is crystal and clear when it comes to the logic gates. Guys, give me the signal in the chats. Is this crystal and clear? Everyone means everyone. I would want you guys to tell me in the chats if this is crystal and clear. With the fire emojis. And smash the like button if you have not liked the session yet. Now, guys, next. Next we have the hydrogen spectrum and Bohr's model. Hydrogen spectrum and Bohr's model. Extremely important. Extremely important. Okay. See, guys, take a look. Take a look. And more specifically, we have to understand emission spectrum. Okay. More specifically, we have to study the emission spectrum. Guys, take a look at this particular topic. I want you to understand very, very, very carefully. Everybody over here, everybody over here. Listen, guys. Everybody of you know that when it comes to an atom, we say at the center of the atom, it has nucleus, okay? And around the nucleus, electrons are revolving in the orbits. This path, this circular path is called orbit. And this will be the second orbit. This is the third orbit and so on, okay? So electrons revolve in the different orbits. Now, guys, let's suppose this is the atom that we have exactly over here. Listen carefully. If I'm saying that an atom is revolving in the second orbit, an atom is revolving in the second orbit. Okay. Now, if this an electron is revolving in the second orbit. What am I saying? This is the atom. An electron is revolving in the second orbit. Okay. Now, if I say this electron makes the transition from second orbit to the first orbit, means from higher orbit to the lower orbit. If an electron makes the transition from higher orbit to the lower orbit, in that case, energy is released. Energy is released. Remember this. If an electron makes the transition from higher orbit to the lower orbit, energy is released. Energy is released in the form of what? Photon. Photon. We say photons. Photon is the packet of energy. Okay. We say light is made up of, if I say light, sir, light is falling on my hand. These are the photons falling on my hand. So these photons are the energy packets. So if an electron makes the transition from higher orbit to the lower orbit, we say energy is released. Energy is released means photon is released. So this is the photon which is released. Now, you put a screen over here. This is the photographic plate or a screen over here. Now this photon strikes on the screen. Okay. And we say a bright line is formed. A bright line is formed over here. What does this formation of bright line mean? It means that an electron has made the transition from higher orbit to the lower orbit. Okay. An electron has made the transition from higher orbit to the lower orbit. So an energy has been released. So photon is released, and which that photon falls onto the screen. Okay. That photon falls onto the screen, and due to which a line is formed. Okay. Now, if this is a yellow line, means the wavelength of this is matching with the wavelength of yellow. If this is red, wavelength of this is matching with the wavelength of red. Forget about that. Forget about that. Simply what I'm trying to say, if an electron makes the transition from higher orbit to the lower orbit, a photon is released. That further falls on the screen, a bright line is formed. That's it. That's it. This is called emission spectrum. Formation of these bright lines on the dark background is called emission spectrum. That's the point. Now, when it comes to the spectral series, okay, you have got different spectral series. What does spectral series mean? Spectral series means, guys, I would want you guys to understand this scenario in this Lyman series, in this spectral series. Sir, what does that mean? I'll make you understand. What does it actually mean? I'll make you understand. What does it actually mean? I'll make you understand. Okay. So basically, when an electron moves from higher orbit to the lower orbit, a line is formed on the screen. Now, in the spectral series, we show it like these lines. Like. Guys, see. What is this? This is the first orbit, or we also call it the ground state. This is the second orbit in which electrons are revolving. Third orbit, fourth, fifth, and so on. In the spectral series, we show these orbits with the help of straight lines. This line, this line, this line, this line, this line, this line. First orbit, second orbit, third orbit, fourth, fifth, and so on. Okay, now guys, if I say, I'm making this line over here, what does this line actually mean? It means that when an electron has made the transition, it has moved from n is equal to n is equal to 1. So, higher orbit to lower orbit, a line has been formed on the screen. That line I am showing over here. This is the first line of Lyman series. Okay. If an electron has moved from n is equal to 3 to n is equal to 1, we show it with this line, second line. In reality, I have told you its field. Okay. And if an electron has moved from, we say n is equal to 4 to n is equal to 1, this is the third line. Okay. And if an electron has moved from n is equal to 5 to n is equal to 1, this is the fifth line. N is equal to infinity to n is equal to 1. So means in Lyman series, this is also called K series. We say final orbit of the electron is 1. Finally, electron has to come to 1. And initial orbit can be, initially electron can be 2, 3, 4 and so on up to infinity. So in the Lyman series, we show only those transitions where an electron has moved from higher orbits to the first orbit. Is this clear? Is this clear? So for first orbit, n is 1. For second orbit, n is 2. For third orbit, n is 3 and so on and so on. Is this clear? Please tell me in the chats. Is this clear? Please tell me in the chats. Okay. Okay. Yes. Now guys. If an electron has made the transition from higher orbits to the second orbit, then we show that in the Balmer series. That transition we represent in the Balmer series. Okay. So we say in Balmer series, final orbit is 2. Initial orbit is, we say 3, 4, 5 and so on up to infinity. Okay. So this is the first line of Balmer series. This is the second line of Balmer series, third line, and we say the fourth line. Okay. And always remember one more thing, guys. This first line, it has got, I would mention over here, this first line has got the minimum energy and minimum frequency. So this, guys, what I'm trying to say is that if an electron makes the transition from second orbit to the first orbit, the energy which is released, the photon which is released will be less as compared to the second line, as compared to the third line. Okay. So this first line has got minimum energy, minimum frequency, okay, but maximum wavelength. Please remember this directly. Whatever I say, remember it. Maximum wavelength. Okay. So if an electron has made the transition from n is equal to 3 to n is equal to 2, this is the first line of Balmer series, second line, third line, and so on. This is the last line of Balmer series. Okay. So first line has got the minimum energy and minimum frequency, and last line has got the maximum energy and maximum frequency. Now. Then we have the Paschen series. In case of Paschen series, if an electron has made the transition from n is equal to 4 to n is equal to 3, so here final orbit is 3, initial orbit can be 4, 5, 6 up to infinity. So we show those transitions in Paschen series. In Lyman, we show transitions only if the transitions are made from higher orbits to the first orbit. In Balmer, we show only those transitions if the transition is made from higher orbit to the second orbit. In Paschen, we show only those transitions in which an electron has moved from higher orbits to the third orbit. So first line, it has got maximum wavelength, minimum energy, minimum frequency. Okay. Last line, maximum energy, maximum frequency, minimum wavelength. Okay. Similarly, then you have bracket series. Final orbit is 4, initial orbits can be this. Okay. Then you have P-fund series. That's it. Okay. Now guys. Is this clear till over here? Please give me the signal in the chats. Is this clear till over here? I would want you guys to give me the signal in the chats. Is this clear till over here? Everyone means everyone. Is this clear? Is this clear? With the fire emojis. Great. And smash the like button. Okay. Now guys, take a look. I want you to understand one thing. Guys, see, we say When an electron moves from higher orbit to the lower orbit, in that case, you know, sir, photon is released, photon is emitted, okay? And when that photon falls onto the screen, it forms a line. We have shown that those lines on the spectral series also. Now, this photon will have the wavelength. How do we calculate the wavelength of that photon emitted? This is the formula by which we can calculate the wavelength of the photon. Okay. And what is this 1 by lambda? Guys. 1 by lambda is what we call the wave number. Wave number. And sir, what is wavelength? Lambda is what we call the wavelength. Okay. 1 by lambda as a whole is wave number. Lambda itself is wavelength. Okay. And what is this R? R means Rydberg constant. And the value of Rydberg constant is 1.03 in 10 raised power 7 meter inverse. This is the value of Rydberg constant. And this is how we find the wave number of that particular photon emitted. Or you can also say this is the wavelength of any line. Let's suppose an electron has moved from this orbit to this orbit. Okay, photon is emitted. That photon has this is the photon emitted. Okay, or this line. How do we calculate the wavelength of this line? Using this particular formula. Now, this particular formula is important over here. NEET 2017. Now, see question. The ratio of the wavelength of the last line of Bohr series. The ratio of the wavelength of last line of Bohr series. Last line of Bohr series is which one? Last line of Bohr series is which one? This is the first line. This is the last line. For last line, n initial is infinity. Electron has moved from infinity to n is equal to 2. So I can say for the last line, can I say in Bohr series? Can I say for the last line, guys, n final is going to be 2. And what about n initial? N initial is going to be infinity. And how do you calculate the wavelength of this particular line? Guys, you can say 1 divided by lambda is equal to R. Then 1 by n final square minus 1 by n initial square. This is the formula. Extremely important. I can say 1 divided by lambda. This will be R. Now, for the last line, we can say final orbit is 2. So 1 by 2 square is 4 minus 1 by n initial 1 by infinity. So that is 0. So 1 by lambda Bohr I can write over here. That will be R divided by 4. And we can say lambda Bohr will be 4 divided by R. Call this as first. Then it says, and the last line of Lyman series. Last line of Lyman series will be what? Guys. Last line of Lyman series. We say last line of Lyman series. How do we find that? Guys? Sir, for the last line, we say n initial is going to be infinity, n final is going to be 1. Because Lyman series means final orbit is 1. So how do we find the wave number? 1 by lambda is equal to R into 1 final square, 1 by n final square. N final is 1 minus 1 by n initial, that is infinity. So can I say 1 by lambda Lyman, it is going to be R by 1. Do the reciprocal. 1 by lambda Lyman, or we say lambda Lyman is going to be 1 by R. Now you have to find ratio of Bohr, last line of Bohr series upon last line of Lyman series. How do you say? Sir, last line of Bohr divided by last line of Lyman is going to be 4 by R upon 1 by R. So that is. So 4:1 is going to be there. This is how we exactly do it. NEET 2016. NEET 2016. Now guys, take a look. Given the value of Rydberg constant is 10 raised power 7. Okay. meter inverse. The wave number for the last line of Balmer series in the hydrogen spectrum will be, guys, last line of Balmer series. Balmer series. Now tell me one thing. When it comes to the last line of Balmer series, can I say n final is going to be 2 and initial is going to be infinity? Yes. So now tell me, what will be the value of wave number? Wave number means 1 by lambda. That will be r upon 1 by n final square. 1 by 2 square is 4 minus 1 by infinity. Okay, so 1 by lambda is going to be r divided by 4. Now this is 10 raised power 7. So 1 by lambda will come out to be, I can say, Redberg constant. Okay, given the value of Redberg constant 10 raised power 7. So that is 1 by 4 into 10 raised power 7. So that is 0.25 into 10 raised power 7. This is the value of. Okay. Is that clear? Is that clear? Next. Ratio of the longest wavelength corresponding to NEET 2013. Ratio of the longest wavelength. Ratio of the longest wavelength corresponding to Lyman and Balmer series in the hydrogen spectrum is. Now tell me, longest wavelength. Guys, which one has got the longest wavelength in Lyman and Balmer series? Okay. When it comes to the Balmer series, sir, first line has got the longest wavelength and minimum energy. That's what I was saying. Remember it directly over here. If it is confusing you, remember it. So first line has got the longest wavelength, maximum wavelength. And here also, first line has got the maximum wavelength. So it is talking about the first line. It is talking about the first line. So I can say in this particular case, guys, first line of which one? Lyman series. Okay. And when it comes to Balmer series, I say first line of Balmer series. Balmer series. So these two lines will have the longest wavelength. These two lines will have the longest wavelength. Now tell me one thing. When it comes to the first line, can I say n initial is going to be 2 and n final is going to be 1? For Lyman series, final orbit is 1. If we are talking about the first line, so n initial will be 2. And here in Balmer, n initial is going to be 3 and final is going to be 2. Done. Now, how do we find the wavelength? 1 by lambda is equal to r. 1 by n final square, 1 by 1 minus 1 by 2 square is 4. Okay. Here, 1 by lambda is equal to r. Then 1 by n final square, n final is 1 by 4 minus 1 by n initial square, 1 by 9. Now, do the simplification, then you have to find the ratio. Okay. 5 by 27 will be the correct answer. Yes, exactly. Now you have to find this divided by this. That will come out to be 5 divided by 27. Okay. So lambda Lyman divided by lambda Balmer will come out to be 5 divided by 27. Now, how many of you understood this? Please tell me in the chats, is this crystalline clear with the fire emojis? Guys, tell me in the chats, is this crystalline clear? Everyone means everyone. Everyone means everyone. Everyone means everyone. That's great. Now guys, take a look. Take a look. The next topic we have, photoelectric effect. See guys, what does photoelectric effect mean? Photoelectric effect is an experiment. When light falls on a photosensitive metallic surface, electrons are ejected from the surface. This process is called photoelectric effect. Like, let's suppose I am taking a metallic surface over here, metallic plate, and I'm taking a light source over here. So this is the light falling on this photosensitive metallic surface. Means these are the photons falling. These are the photons falling. Okay. Now, when photons are falling on this photosensitive metallic surface, we say due to the falling of photons, we say electrons are ejecting from the surface. Electrons are ejected from the surface. These are the electrons which are ejected from the surface. This process we have seen. We take a surface, photosensitive metallic surface, and light falls on the photosensitive metallic surface. We saw electrons ejecting. This phenomena, this process is called photoelectric effect. This process is called photoelectric effect. Okay. Now, here we define a term, that is what we call the work function. Here we define a term, that is what we call the work function. It is the minimum energy required to pull the electrons from the material. That is called a work function. Like. Guys. Let's suppose I say, this is a metallic surface. Its work function is 2 electron volts. This is another metallic surface. Its work function is 5 electron volts. What does it mean? It means that if you have to take out the electron from this metal surface, you will have to send a photon. You will have to send a photon which must have the energy of minimum how much? 2 electron volts. That is the work function. Work function means how much energy is required so that you can take out the electron from the metal surface. Okay. Now, if I say 5 electron volts, means here you have to send a photon which must have the energy of how much? 5 electron volts. Then only it can take out the electron. So what if this photon has less than the energy as work function? Then it cannot take out the electron from the metal surface. That's the condition. Okay. So work function depends upon the material. Different materials can have different work function. On one material has got work function 2, another can have 50. Okay. Depends. So minimum amount of energy required to take out the electrons from the metal surface. Now see, this is the photoelectric effect setup. One equation I'll make you understand, that is this. This is basically a tube-like structure, okay, where we perform the photoelectric effect. This is a metallic surface called cathode. This is the metallic surface called anode. This is the opening over here. This is a light source. So light falls on this metallic surface. So these are the photons coming out. Okay, it falls on the metallic surface. Due to this, we say electrons are coming out. Due to this, electrons are coming out from the metal surface. Okay. Now, when photons fall on the metal surface, energy falls onto the metal surface, we say electrons come out. Okay. Now guys, see. I say, let's suppose energy of a photon is falling on the surface, its energy is 8 electron volts. Work function of this metal is, let's suppose, 2 electron volts. What does that mean? Work function means how much energy is required so that an electron is taken out. That is 2. So my dear friends, when you send a photon of 8 electron volts, the electron absorbs that energy, 8 electron volts. Now, 2 electron volt it is using so that it can come out of the metal surface. Okay, 2 electron volt, because that is work function. Now, 8 minus 2 is 6. Where will the 6 electron volt energy go? Sir, when electron comes out, then it has to move forward to produce photocurrent. So for that, kinetic energy is required. So that 6 will go in the kinetic energy. Okay. So guys, what I'm trying to say, if this is the metal surface, the photon has got 8 electron volt. Now photon falls. Now here inside this, it has electron. That electron absorbs the energy. Now, electron has got how much energy? 8. 2 electron volt it is using so that it will come out of the metal surface. Rest of the 6 it is using so that it can move forward to produce current. Okay. Now, can I say energy of photon is used in the work function and kinetic energy maximum and kinetic energy maximum. That's it. Work function and kinetic energy maximum. Even you can write it something like this also. Guys, see, energy of a photon is equal to work function plus kinetic energy maximum. Guys. Further you can write it like this. I want you to understand. See. This energy of photon, it is equal to h into f. Always remember, energy of photon is h means Planck's constant, f is frequency. When Planck's constant and frequency are multiplied, it gives the energy of photon. This is energy. This work function is also energy. We say it is equal to h into f naught. Okay. F naught is threshold frequency. Minimum energy required. Minimum energy at which the minimum frequency at which the photoelectric effect takes place. Okay. So h into f naught plus kinetic energy we can write 1 by 2 m v square. We can write 1 by 2 m square. You can write this photoelectric equation something like this. Okay. Now, that's it. Now, let's move on to the question. For a certain metal, this nu, you can say this is frequency. F is 5 times f naught. F naught is threshold frequency. The maximum velocity of the coming photoelectron is 8 in 10 raised power 6. If f is 2 times of f naught, then the maximum. See, what does it say? It says that if you have a metal surface over here, okay, if you are sending a photon on this metal surface, okay, which has the frequency f is equal to 5 times of f naught, 5 times threshold frequency. Threshold frequency is that frequency at which photoelectric effect takes place. Sir, what if the photon has less than this frequency? Then photoelectric effect will not take place. Then it cannot take out the electron. Keep that thing in your mind. Okay. We say due to this photon, electron comes out. It has got how much velocity? V1 is equal to 8 into 10 raised power 6 meter per second. 8 into 10 raised power 6 meter per second. Okay. Yes. Now guys, we say if another photon falls onto this, and the frequency of this photon is 2 times of f naught. The frequency of this photon is 2 times of f naught. Now, the electron which will come out, how much will be its velocity? That is the question. Guys. We say in case 1, use photoelectric equation. In case 1, use photoelectric equation. What does that say? Energy of photon is equal to work function plus kinetic energy maximum. Energy of photon, h into f is equal to h into f naught plus 1 by 2 m v1 square. Because here velocity of electron is v1. Now h into f. What is the frequency of photon over here? 5 times f naught. So 5 times h f naught is equal to h f naught plus 1 by 2 m v1 square. 5 times h f naught minus h f naught. So it will be 4 times h f naught is equal to 1 by 2 m v1 square. Call this equation first. Okay. Now use the same equation in case 2. In case 2, I can say, sir, h into f is equal to h into f naught plus 1 by 2 m v2 square. So h into f. So you guys will write over here H into F. What is the frequency over here? That is 2 times of F is equal to HF naught plus 1 by 2 m V2 square. 2 minus 1 is 1. So HF naught is equal to 1 by 2 m V2 square. Call this as equation second. This is first, this is second. Now divide first and second. We say divide first and second equation. Divide first and second. When you divide first and second, you will be writing 4 HF naught divided by H divided by HF naught is equal to 1 by 2 m V1 square divided by 1 by 2 m V2 square. This and this will cancel, this and this will cancel. So V1 by V2 whole square is 4. So V1 divided by V2 will come out to be, square will go over here, root 4, that is 2. So V2 will come out to be V1 divided by 2. What is the value of V1? 8 into 10 raised power 6. So 8 into 10 raised power 6 divided by 2. So that will be 2 4s are 4 into 10 raised power 6 meter per second. How many of you understood this? Tell me guys. Tell me guys. Tell me guys. Is this clear? With the fire emojis. Just make the first equation over here. Just make the second equation over here. Divide the two equations. Like one more question of the same pattern. Like one more question of the same pattern. See, two radiations of photon energy, 1 electron volt and 2.5 electron volt. Okay. Two radiations of photon energy, 1 electron volt. A photon is falling, its energy is 1 electron volt. Another photon is falling, its energy is 2.5 electron volts. Okay, falls on a photosensitive material, which has got a work function of phi is 0.5 electron volts. The ratio of the maximum speeds, we said due to this electron, due to this photon, electron comes out, it has got velocity v1. Due to this, another photon comes out, it has got velocity v2. We have to find v1 divided by v2. That's it. Similar question, similar pattern. Similar question, similar pattern. Similar question, similar pattern. Now tell me guys, in this case, can I say here? If I say in case 1, if I say here, use photoelectric equation, what does that say? Energy of a photon is equal to work function plus kinetic energy maximum. Okay. Now tell me, energy of a photon, that is 1 electron volt, is equal to work function, that is 0.5 electron volt plus kinetic energy maximum 1 by 2 m v1 square. Okay. 1 minus 0.5, that is 0.5. Okay. So I can write over here, that is 1 by 2. Okay. Electron volts is equal to 1 by 2 mv1 square. Call this as equation first. Now, when I say in case 2, can I say energy of a photon is equal to phi plus kinetic energy maximum here also? And in case 2, energy is 2.5. So 2.5 is equal to 0.5 electron volt plus 1 by 2 m v2 square. Okay, 2.5, so this will come out to be 2 electron volt is equal to 1 by 2 m v2 square. This is the equation second. Now guys, in this particular case, we say divide first and second. So I would say divide first and second equation. So if you divide first and second, what will you write? That is 1 by 2 into 2, that is 1 by 4. 1 by 4 is equal to 1 by 2 mv1 square upon 1 by 2 mv2 square. This and this will cancel. Okay. Now tell me in this particular case, so I can write v1 divided by v2 whole square. Okay. And this will come out to be 1 by 4. Okay. Now take this over here. This will be a root. So V1 divided by V2 will come out to be 1 by 2. Is that clear? Is that clear? Okay. Is that clear, guys? Next, important topic. Matter wavelength or de Broglie's wavelength. Guys, listen to me very carefully. I would want you guys to join my Telegram channel. What is that? That is t.me/YAWAR Okay. In this Telegram channel, I share all the notes, all the important, we say, uh, notifications, whatever it is. This is my personal Telegram channel. Okay. And one more important thing, guys. Whatever the concepts I told you in that particular video, I'll be completing all of those concepts, provided if you stick with me when it comes to these particular sessions. Okay. So you'll have to be regular. If you are not regular, then don't expect. Okay. If you are regular, then I'll complete all those 25 topics which I have told you in that particular session, from which the questions are 100% guaranteed. Okay. Now, take a look. Matter wavelength. Okay, matter wavelength. Okay. Will you stick to all these sessions? Come on, tell me in the chats. I'm looking. Tell me in the chats. Will you stick to all these sessions? Smash the like button if you have not liked the session yet. Yeah, that's great. I'm regular and I'm your neighbor also, sir. Where are you from, Yawar Manzoor? Okay. Now, guys, take a look. de Broglie's wave. Guys, see, this is also called a matter wavelength. Everything in this universe has a wave nature, and a wave is associated with it. It is called matter wave or de Broglie's wave. Everything in this universe, whatever you see, sir, this pen, is this a wave? Yes. Sir, is this a particle? Yes, we can feel its particle nature. Okay. Sir, is this a wave also? Yes, this is a wave also. Okay. Now, my dear friends, if everything, you, me, this board, this pen, marker, everything is a wave, and it has got a wave nature, it has got a wavelength. How do we calculate the wavelength of this particle? We say lambda is equal to h is Planck's constant, divided by mv. mv means momentum, because p is equal to mv. So, if you have a particle, its mass is m, it's moving with velocity v. If somebody asks you how to find its de Broglie's wavelength, you'll say, sir, it is h divided by mv. h divided by mv. That is the de Broglie's wavelength of this particle. So, what will you say? Sir, everything in this universe you see is a wave. Okay, like, is this t-shirt a wave or particle? This is a particle as well as wave. How to calculate its wavelength? Sir, lambda is equal to h divided by mv. Now, guys, listen. We say, sir, the general formula or the basic formula of de Broglie's wavelength is h divided by mv. Sir, is there any other form of de Broglie's wavelength? We say, guys, let's see. We say as lambda is equal to h divided by mv. Tell me one thing. We say kinetic energy is equal to 1 by 2 mv square. You know it, yes. Do one thing. Multiply with m and divide with m. So you'll be writing over here, kinetic energy will come out to be, that is m square v square divided by 2m. Take this 2m over here. So this will be 2m kinetic energy is equal to m square v square. Now, take the square over here. So mv will come out to be under root of 2m ke. Now, this is the value of mv. If you put this mv over here, can you write lambda will come out to be h upon, instead of mv, you will be writing under root of 2m ke. Sir, is this also the form of de Broglie's wavelength? Yes, this is also the form of de Broglie's wavelength, but in terms of what? In terms of what? This is also the form of de Broglie's wavelength in terms of kinetic energy. In terms of kinetic energy. Okay. So we say this is the de Broglie's wavelength in terms of kinetic energy. Lambda is equal to h upon under root of 2m ke. Sir, is there any other form? Yes. We said de Broglie's wavelength for a relativistic particle. Sir, relativistic particle means which particle? Relativistic particle is that particle which has the speed comparable to the speed of light. Okay, comparable to the speed of light. So my dear friends, see. We say velocity almost equal to the speed of light. See, like you have electron, proton. Those particles which are moving extremely at a faster speed, they have got the de Broglie's wavelength of this one. H under root of 1 by v square by c square upon m naught into v. Okay, Planck's constant. Okay, v is the speed of that particle. C is the speed of light. M naught is the rest mass of that particle. V is the velocity of that particle. Okay. Now, if there is a charge accelerated with some potential difference, okay, you have a charge, you are accelerating it with some potential difference. What is its de Broglie's wavelength? H upon under root of 2mq delta v. Important expression, okay? H upon under root of 2mq delta v. Sir, if there is a charge placed at rest in the external field, sir, you have placed a charge in the external electric field. Okay, this is the charge q. This is placed in the external electric field. How much will be its de Broglie's wavelength? H upon QET. Q is the charge, E is the electric field, T is the time, after time t. Now, charged particle placed in the magnetic field. If you have placed a charged particle in the magnetic field, like this is the inward magnetic field B over here. In this magnetic field, you have placed a charge Q. Okay. Now, in this particular case, my dear friends, always remember, see guys, whenever you place a charged particle in the magnetic field, okay, perpendicularly, it will perform the circular motion. It has got the radius r, okay, and charge is, let's suppose, q. How much will be its de Broglie's wavelength? H upon QBr. Q is the charge, B is the magnetic field, R is the radius in which it is moving. Radius of that circle in which it is moving. Now, for a gaseous molecule at temperature T, okay, we say H upon under root of 3m kBt. Kb is the Boltzmann's constant and T is the temperature. Okay. For an electron moving in the nth orbit of an atom. Sir, if I say second orbit, n is equal to 2. If I say third orbit, n is equal to 3. Okay. Now, my dear friends, we say lambda is equal to nh divided by under root of 2m into 13.6. So this will be the de Broglie's wavelength in that particular particle. Okay. So see, when it comes to the matter wave, so people asked de Broglie, why cannot we see this matter wave? He said there are a lot of waves which you cannot see. Similarly, you cannot see the matter wave. Okay. If you ask me, sir, what is the proof for this? Lambda is equal to h divided by mv. There is no proof. Sir, did de Broglie give any proof, like any solid proof that this is the matter wavelength? Okay. This is the matter wavelength. No, there is no proof for this. He was a law student. He was not a physicist. He just gave it. He said, divide Planck's constant with momentum, you will get the de Broglie's wave. And people asked you, why cannot we see this wave? He said, there are a lot of waves which you cannot see. That's why we are not able to see this particular wave also. Similarly, you are not able to see this wave also. Okay. So lambda is equal to nh upon 2 under root of 2m into 13.6. So this will be the de Broglie's wavelength for an electron moving in the nth orbit of an atom. Okay. So these were the de Broglie's wavelength for different particles. Okay. Is this clear? Now you have got a question which was asked in NEET JEE Mains 2021. See guys. The following have got the same kinetic energy. Which one has got the longest de Broglie's wavelength? Guys, see. Which one? Alpha particle, proton, neutron, electron. Guys, see. When it comes to the alpha particle, okay, when it comes to the neutron, okay, when it comes to the proton, okay, when it comes to the electron, always remember, guys, mass of alpha particle is greater than mass of neutron is greater than mass of proton is greater than mass of electron. Okay, yes. Okay, yes. Now, guys, see. If I say all these particles have got the same energy, we say as. De Broglie's wavelength, lambda is given as h upon under root of 2m kinetic energy. Now, kinetic energy for all the particles is same. Planck's constant for all the particles is same. Okay. And my dear friends, we say lambda is inversely proportional to mass. The one which has got the more mass, large mass, will have less de Broglie's wavelength. So can I say lambda for alpha is less than lambda for neutron is less than lambda for proton is less than lambda for electron. So which one has got the largest de Broglie's wavelength? Obviously it is electron. And this is the order. Okay, this question was, by the way, asked multiple times in the JEE. What about this one? The ratio of velocity of proton and alpha particle, if the de Broglie's wavelength of both the particle is same, it is saying that de Broglie's wavelength of alpha particle is given as de Broglie's wavelength of proton. Guys, how do we write h divided by mass of alpha particle, velocity of alpha particle is equal to h divided by mass of proton into velocity of proton? This is how we write. Yes. Now tell me, can I say in this particular case, this will be h upon mass of alpha particle? Guys, always remember, mass of alpha particle is 4 times mass of proton. Mass of alpha particle is 4 times mass of proton. So I'll be writing over here, this is 4 times mass of proton, okay, into velocity of alpha particle is equal to h divided by mass of proton into velocity of proton. H will cancel, MP will cancel. Okay, so take it over here. Velocity of proton divided by velocity of alpha particle will be 4:1. Is this clear? Okay, is that clear? Is that clear, guys? Guys, let me know in the chats if this is crystalline clear to each and every single student. Now, guys, let's move on to the next question. This question was asked in. This question was asked in. This question was asked in. We say NEET 2016 and IIT 2021. What does the question say? Guys. An electron and a photon have got same energy. You have got electron and you have got photon. Okay, they have got the same energy. The ratio of de Broglie's wavelength associated with the electron and the wavelength of the photon is, guys, see. When it comes to the electron, guys, I'll write for an electron. For an electron, I would want you to understand one thing. Can I write de Broglie's wavelength for an electron? De Broglie's wavelength for an electron. It is h upon under root of, we say 2m into E. We are saying E means kinetic energy. When it comes, let's suppose you have an electron. How do we write its de Broglie's wavelength in terms of kinetic energy? H upon under root of 2m into E. And when it comes to a photon, guys, I want you to understand here, we say for a photon, how do we write its de Broglie's wavelength? We say energy of a photon is hc divided by lambda. This is how we find the energy of a photon. Guys, please remember this formula. H is Planck's constant, c is speed of light, lambda is de Broglie's wavelength. So from here, we can say energy of a photon will be hc divided by E. Since it says that both electron as well as photon, they have got the same energy. Both electron as well as photon, they have got the same energy. That's why E over here. Now you have to find the ratio of de Broglie's wavelength of electron and photon. Now you have to find de Broglie's wavelength of electron divided by de Broglie's wavelength of photon. Okay. Now it will be that is h divided by, we say under root of 2m into E, then whole divided by, we say hc divided by E. Now guys, tell me one thing. Can we write it something like this? This will be h upon under root of 2m into E multiplied by, take this in the numerator, E upon h into C. This and this will cancel. Now, can I further write it something like this? This will be lambda of electron upon lambda of proton. It will be something like this. Guys, it is 1 by C, then 1 by under root of 2m into E, and then you have E in the numerator. I want you to multiply with root E and divide with root E. Now guys, here we say root E into root E is E. That E cancels with this E. So further, my dear friends, I can write over here lambda of electron divided by lambda of proton will come out to be, that is 1 by C. This is root E. I can write it something like this, under root of E divided by 2m. Now I can say it something like this, 1 by C. and this will be E divided by 2m. Value of root is 1 by 2. Now check which of the option is matching. 1 by C, E divided by 2m, whole raised power 1 by 2. Okay? Okay. Is that clear? Is that clear? All the lovebirds in the chats, tell me, is this clear? And smash the like button, okay? Don't leave without smashing the like button. Otherwise, you will be smashed. Keep that thing in your mind. Next one. Next topic. Next topic. Guys, take a look. I have told you previously, I will be completing all the 25 topics which I have mentioned in that particular video. Okay? 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 Now it depends how many sessions it will take, whether it will take one session, whether it will take two sessions, or whether it will take 3 sessions. Okay? Now don't ask the same question again and again. Your motive is you should be able to gain maximum marks with those 3 sessions. So stick to this. That's it. Is this clear? Now guys, take a look. Now guys, take a look. We say mathematical analysis of Bohr's theory. Guys, see. What does this actually mean? See. When it comes to the Bohr's model, Bohr's atomic model, Bohr said that if we talk about an atom, this is the atom. Let's suppose this is the atom over here. Okay. We have got the atom over here. Okay. In an atom, at the center of the atom, we have got the nucleus. At the center of the atom, we have got the nucleus. Okay. At the center of the atom, we have got the nucleus. Okay. And around the nucleus, you have an electron. Around the nucleus, you have an electron revolving around the nucleus. Okay. Yes. At the center of the atom, you have the nucleus. Around the nucleus, you have an electron. Around the nucleus, you have an electron. Okay. Now, guys, listen to me very carefully. This nucleus has got the charge Ze. Ze is the charge of the nucleus. What is this Z? This Z means the atomic number. Like for hydrogen, atomic number is 1. We say Z is, I'll write over here. We say Z is atomic number. Okay. Z is atomic number. Okay. And N means nth orbit. If we talk about the first orbit, for first orbit, N is 1. If we talk about the second orbit, for second orbit, N is 2. For third orbit, N is 3. Okay. So if this is when it comes to the Bohr's model, he said an electron revolves around the nucleus. This nucleus has got the charge Z. Okay. E is the charge on an electron. Z is this. Okay. Or charge on proton is positive, electron is negative. And here this is the electron revolving. This electron has got a velocity v. This electron has got a velocity v. And this radius is r. Now, if somebody says, what is the value of this velocity? Directly you will say, sir, velocity of an electron in the nth orbit. So that is 2.2 into 10 raised power 6 Z by N. Z is the atomic number. For hydrogen it is 1, helium it is 2, lithium it is 3. Okay, then N means nth orbit. This is the velocity of an electron in nth orbit. Instead of this, you can write V naught. Now, similarly, you can say radius of an electron in the nth orbit. If an electron is revolving in the nth orbit, we say in that particular case, radius is 0.53 angstrom. N square divided by Z. R is equal to R naught N square by Z. This is the radius of an electron. So means if an electron revolves in the nth orbit of an hydrogen atom, how much will be its radius? This one. And how much will be its velocity? This one. Okay, yes. Okay, yes, 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 yes. Let's suppose, find the radius of Li2 positive ions in its ground state, assuming that Bohr's model to be valid. So guys, when I say Li2 positive, for Li2 positive, Z is 3 atomic number. You have to find the radius. What is the value of radius? R naught n square by Z. And electron is in the ground state of Li2 positive. Ground state means n is equal to 1. First orbit. So I can write in that particular case, R is equal to R naught. Instead of R naught, you can write over here 0.53 angstrom. Angstrom means 10 raised power minus 10 if you convert to the meters. Okay. N is 1 divided by, we can say 3 over here. And solve and get the answer. This will be the radius. Similarly, find the maximum angular speed of an electron of a hydrogen atom in the stationary orbit. That is the ground state. I see. It says angular speed. Angular speed means you have to find the omega. If a particle is doing the angular motion, it will have angular speed, that is omega. Tell me one thing, we say V is equal to R omega. How many of you have seen this particular equation? Now, can I say here, we say this omega will be equals to V divided by R? Yes. If you want to find the angular speed of the electron in the nth orbit, V by R. Now, see. Can I say this omega will be, what is the value of V, velocity of an electron in nth orbit? V naught Z by N. V naught is 2.2 into 10 raised power 6 Z by N. Then we say upon. This is 0.53 into 10 raised power minus 10. 10 raised power minus 10. We say N square divided by Z. Now, tell me one thing in this particular case. Guys, here 2.2 into 10 raised power 6 Z by N. So, Z, when we talk about the hydrogen atom, stationary orbit, hydrogen atom, for hydrogen atom, Z is 1, stationary orbit, N is 1. So, can I say this is going to be 1 by 1, 1 by 1. So, this is going to be 2.2 divided by 0.53, and this is 10 raised power 6 and 10 raised power minus 10. So it is going to be 10 raised power 6 into 10 raised power plus 10. Because if you take this in the numerator, it will become plus 10. So this will come out to be 4.1 into 10 raised power 16 rad per sec, radian per second. This is the angular speed. Okay? Is this clear? Similarly, my dear friends, we say time period of revolution of an electron in the nth orbit. Time period of revolution of an electron in the nth orbit. Like if this is the electron revolving in the nth orbit of hydrogen atom, how much will be its time period? Time period means how much time it is going to take in completing one cycle. The time period will be 1.51 into 10 raised power minus 16 n cube by z square. Okay, this will be the time period. Next, important, total energy of an electron in the nth orbit. Total energy of an electron in its nth orbit. Total energy of an electron in its nth orbit. Tell me one thing, guys. This is the nucleus. Okay. Now, this is the electron which is revolving. It has mass m. It has velocity v. If you have an object which has mass, which has velocity, we say it has kinetic energy. So, kinetic energy of an electron in its nth orbit, that is Z e square upon 8 pi epsilon naught r. Z e square upon 8 pi epsilon naught r. Z e square upon 8 pi epsilon naught r. When it comes to the potential energy, that is minus Z e square upon 4 pi epsilon naught r. Z e square upon 4 pi epsilon naught. Okay, guys, kinetic energy is due to the motion. Potential energy is if you have one charge, if you have another charge. When you have two charges separated by some distance, they have got the potential energy. Okay, guys, remember, when it comes to the kinetic energy of an electron in nth orbit, that is Z e square upon 8 pi epsilon naught r. Z is atomic number, r is the radius. E is the charge on an electron. Epsilon naught is what? Permittivity of free space. Similarly, this is potential energy is negative, minus Z e square upon 4 pi epsilon naught r. And total energy is minus Z e square upon 8 pi epsilon naught r. 8 pi epsilon naught r. Okay, okay. Guys, see. If you take this total energy, understand this very carefully. I'll write total energy is equal to, we say minus, we say E square, then we say Z upon, here it is 8 pi epsilon naught. Can I write value of R as R naught N square by Z, N square divided by Z. That Z I'll take over here, Z into Z becomes Z square. Now see, charge on an electron 1.6 in 10 raised power minus 19, epsilon naught 8.85 in 10 raised power minus 12, R naught 0.53 into 10 raised power minus 10. Okay, if you put all of these values and then you solve, total energy comes out to be equal to minus 13.6 Z square by N square. Total energy comes out to be minus 13.6 Z square by N square. That is this. Okay. So this is also the total energy of an electron in the nth orbit. Now, if I say hydrogen atom, for hydrogen atom Z is 1, put Z 1, total energy will be minus 13.6 by N square. One more point. Guys, you see, kinetic energy and total energy, both are exactly equal. This is negative, this is positive. This is negative and this is positive. So my dear friends, in this particular case, we say total energy is this, kinetic energy is this. So whatever is the value of total energy, same as kinetic. This is negative, this is positive. This is negative, this is positive. Now tell me, is this clear? Everybody out there, is this clear, guys? Is this clear? I hope this energy is clear. Now, guys, let's suppose if someone says, what is the energy of and total energy of an electron in the first orbit? Let's see. In the first orbit, n is equal to 1. In a hydrogen atom, you said total energy will come out to be, that is minus 13.6 divided by 1 square. That is minus 13.6 electron volt. If I say, what is the total energy of an electron? What is the total energy of an electron of hydrogen atom in the second orbit? We say n is equal to 2. Total energy will come out to be, that is minus 13.6 divided by 2 square is 4. That will be 3.4 electron volts. Okay. If I say n is equal to 3, what is the total energy of an electron in the third orbit of hydrogen atom? Minus 13.6 divided by 3 square is 9. That is 1.51 electron volts. Similarly, in fourth, 0.56 and so on. Okay. I hope these points are also clear. Now take a look. This is a previous year question. NEET 2020. The total energy of an electron in an orbit is 3.4 electron volts. Okay? Is minus 3.4 electron volt. Total energy is given as minus 3.4 electron volts. its kinetic and potential energies will be. Guys, tell me, when it comes to the kinetic is exactly same as total, but it is positive. So that will be plus 3.4 electron volt. And when we say total energy is always equal to potential energy plus kinetic energy. So total energy is minus 3.4. Potential energy we need to calculate plus kinetic energy is 3.4. 3.4, if you take it over here, minus 3.4, minus 3.4, minus 3.4, minus 6.8 electron volt is equal to potential energy. Okay. Okay. Tell me, is this clear till over here? Is this clear till over here? Everybody out there? That's great. That's great. The electron in an hydrogen atom jumps from excited state n is equal to 3 to its ground state n is equal to 1. An electron jumps from the n is equal to 3. N is equal to 3 to n is equal to 1. Okay? N is equal to 3 to n is equal to 1. Whenever electron jumps from higher orbit to the lower orbit, tell me one thing. We say photon is released. Okay, energy is released in the form of photon. Yes. What will be the energy of that photon? Guys, remember, energy I'm talking about, not the wavelength. We say energy will be if an electron moves from n is equal to 3 to n is equal to 1, energy will be, guys, energy will be energy of that photon. That is, we say energy gap between the two. That is this energy minus this energy. This energy minus this energy. Okay. So that will be over here. Energy in third minus energy in 1. Guys, how much that will be? Energy of an electron in the third orbit. Hydrogen atom it is talking about. Sir, that is minus 1.51 electron volt. Then we say minus. Energy of an electron in the first orbit. That will be minus 13.6. Minus 13.6. We say minus 1.51. So that is going to be, we say 12.1 electron volts. Okay, 12.1 electron. Now guys, in this particular case, guys, remember, if an electron moves from higher orbit to the lower orbit, the photon which is released, that will have the energy equal to the energy gap between the two. This energy minus this energy, that is this energy gap. Now, if a photon is released, this photon further falls on a photosensitive metallic surface. Okay? Photosensitive metallic surface. It further falls on the photosensitive metallic surface. Okay? When it falls on the photosensitive metallic surface, electron will be emitted. That's what it is saying. And thus photon falls on the photosensitive metallic surface, which has got the work function of 5.1 electron volt. We say electron will be emitted from this. Means photoelectric effect is taking place. Yes. It says, what is the stopping potential? As what is the stopping potential? Stopping potential, I'll say. See? If I say energy of a photon is equal to work function plus kinetic energy maximum. Directly remember this. You can write it something like this. Guys, energy of a photon is equal to work function plus. There is one more formula of kinetic energy. That is EV naught. Sir, 1 by 2 mv square also, EV naught also. E is the charge on an electron. V is what we call the stopping potential. Stopping potential. That potential at which photocurrent becomes zero. Right now, you remember V naught is the stopping potential. Now tell me, guys, can we use the photoelectric equation here? Energy of a photon is equal to work function plus EV naught. Yes, kinetic energy maximum. Energy of a photon, that is 12.1. Okay. Work function is 5.1 electron volt plus EV naught. Now 12.1 minus 5.1, that will be 7 EV naught is equal to EV naught. 7 EV electron volt is equal to EV naught. E and E will cancel. So stopping potential will come out to be 7 volts. This is the answer to this question, and this is a previous year question, by the way. This is a previous year question, by the way. 7 volt is the correct answer. This I'll give you as homework. Simple question. Okay. Now take a look. Radioactive decay. Radioactive decay. Beta decay, beta plus decay, alpha decay. Okay. Radioactive decay. Take a look at this particular topic, guys. Now, guys, see. Listen to me very carefully. Before the radioactive decay, I would want you guys to understand one thing. Let's suppose when it comes to an atom, at the center of the atom, we have got the nucleus. Okay, nucleus. Guys, understand this. I'm starting from the basics, from the scratch. At the center of the atom, we have got the nucleus. Inside this nucleus, we have protons, we have neutrons, protons, neutrons, 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 protons, protons, neutrons. So inside nucleus, there are two types of particles, protons and neutrons. These are what we call the nucleons, okay? Protons have got positive charge, neutrons are neutral. And around the nucleus, you have the electrons revolving. Listen. Law of radioactivity is deleted. When it comes to the radioactive decay, alpha, beta, gamma, it is not deleted. It is there, okay? You want to learn this? Learn it. Law of radioactive decay is deleted. That is separate thing, different thing. Okay. Radioactive decay. Law of radioactivity is deleted. Not radioactive decay. Okay. You want me to skip this topic? Okay. Let's skip it. Okay, let's skip it. Alpha, beta, gamma. Question will be in the NEET 2025, so let's not do this. Let's not do this. Let's do some other topic. Okay. Then listen over here, man. Now take a look. See? So we say when it comes to the nucleus, inside the nucleus you have neutrons and you have protons. Okay, and these are what we call the nucleons. Now let's suppose if there is a nucleus, it has got large number of protons. It has got extremely large number of protons. Huge, and few neutrons. We say this nucleus is unstable. Okay. Why? Because here electrostatic repulsion between the protons will be extremely huge. So chances are there this nucleus will break. Now guys, if you have a nucleus in which you have got extremely large number of neutrons, okay, only less protons, we say this is also unstable. This is unstable. Okay. Now sir, which nucleus is stable? We say that nucleus in which neutron by proton ratio is almost same. We say that is a stable nucleus. Now guys, take a look. We have made a graph between number of neutrons and number of protons. We say we made a graph, experimentally we made a graph something like this. Okay. Now guys, let's suppose if I say, and this is neutron number of neutrons, on this axis number of protons. If I say there is a nucleus A over here, can I say, sir, A nucleus has got less number of protons and large number of neutrons? Now tell me, is this A nucleus stable or unstable? Obviously it is unstable. Why? Because large number of neutrons. Similarly, if we talk about B nucleus has got large number of protons and less number of neutrons. Is this stable or unstable? This is also unstable. Okay, yes. Now guys, we say, sir, what about D nucleus? D nucleus has got large number of protons, large number of neutrons. What about this? This is also unstable. Okay, so we say bigger nuclei, heavy nuclei are also unstable. Large, huge number of nucleons. This is also unstable. Okay, so we say, sir, which nucleus is stable? Please give us some idea. If the mass number is between 30 to mass number is 170. Mass number means, A means mass number. Mass number means number of protons plus number of neutrons. Number of protons plus number of neutrons. If number of protons plus number of neutrons is between 30 to 170, then we say it is a stable nuclei. It should not be less than 30. It should not be greater than 170. Okay. Now guys, this has got mass number, let's suppose, greater than 170. That's why it is unstable. What about C nucleus? Sir, this C nucleus is a stable nuclei. Why? Because it lies on the stability curve. This is what we call the stability curve. All those nuclei which lie on the stability curve are stable nuclei. Okay, yes. Now guys, everybody in this universe, whosoever is unstable wants to become stable. Similarly, I can say, this A nucleus, it is unstable. This nucleus also wants to become stable. So if it is unstable, if it has got large number of neutrons, so in order to attain stability, what will it do? It will basically lose one neutron and the minus n. Why? Because it has got large neutrons, and it will gain one proton. This is the process how it is done. It is not like, sir, it will directly go down. No. It will lose one neutron and it will gain one proton. Or you can understand it like this. One neutron is converted to one proton. Okay. And this process is called beta minus decay. This is one beta minus decay, in which one neutron is converted to one proton. Okay, in which one neutron is converted to one proton. Now, my dear friends, in this particular case, We say, you have got over here, you have got, still, sir, is this stable? No, unstable, because it has not reached the stability curve. Again, it will lose one neutron. It will gain one proton. Till it has not reached, again, it will lose one neutron, one proton. So how many beta minus decay? 1, 2, and 3. After doing 3 beta minus decay, we say it has reached the stability curve. So can I say nuclei A is also unstable because number of neutrons is very large as compared to the number of protons? That is what we discussed. So in order to become stable, it will do beta minus decay. What does that? Neutron is converted to proton. What does that mean? Guys. Listen to me very carefully. Before this, one more thing also. Let's suppose if this is a nucleus, okay, its name is X. If it has 10 protons, if it has 10 neutrons, we represent it something like this. X, we say A is equal to 20. 20 means number of, A means mass number of protons plus number of neutrons. 10 plus 10 is 20. And we say Z is equal to 10. Z means number of protons. This is called atomic number. This is mass number. Number of protons. Okay, this is atomic number. And this is mass number. Mass number means number of protons, number of neutrons. Okay, yes. Now, tell me, if I say, when it comes to the beta minus decay, one neutron is converted to a proton. We write it like this. One neutron is converted to a proton. I see. What is this one over here? This is mass number. When it comes to the neutron, it has got mass number 1. When it comes to the atomic number, it has got 0. Why? Atomic number means number of protons. Proton is a positive charge. So how many positive charge does neutron have? No positive charge. No positive charge. Okay. Why? Because it is a neutral particle. That's why 0. Now, when this neutron is converted to proton, proton has got one mass number. 1. 1 means number of particles. 1. Proton has got one mass number, one positive charge. 1, 1. Now. Can I write it something like this, guys? Let's, in terms of the nuclei, we say you have got a nucleus, okay? In beta minus decay, what will happen to the nucleus? You have nucleus. It has mass number A. Okay, atomic number, let's suppose Z. Now, this X nucleus is converted to Y, or this neutron is converted to proton. Now, tell me, what will happen to the mass number? Sir, if neutron is converted to proton, here one neutron, one proton, particle is same. So, mass number remains same. But sir, it is converted to proton. So, charge is added. So, we say Z plus 1. Atomic number increases by 1. Now, in order to balance this reaction, we add plus electron. Why? Because you are adding one positive charge. So, add one negative charge. Now, what is the charge on left side? 0. What is the charge on right side? Sir, one electron, one positive charge. Cancel, again 0. So, reaction is balanced. Okay. This is called beta minus decay. What I want you to remember, in beta minus decay, we say A remains same, mass number remains same, Z increases by 1. Atomic number increases by 1. Let's talk about the second one. Now, B nucleus. Guys, see, B nucleus has got large number of protons. So, it will do beta plus decay. Okay. Now, my dear friends, in this particular case, we say, here proton is converted to neutron. It will lose one proton, it will gain one neutron. This is called 1 beta plus decay. Okay. 1 beta plus decay. And if this is 1 beta plus decay, so again it has not reached the stability. Again, one more beta plus decay, one more beta plus decay, one more beta plus decay, one more beta plus decay. Finally, it reached the stability curve. So when it comes to the beta plus decay, we say proton is converted to the neutron. Okay, proton is converted to the neutron. So in this particular case, we say proton means one positive charge, mass number is 1. It is converted to the neutron. Neutron has 0 atomic number, mass number is 1. Okay. Now, here positive charge was 1. Here positive charge is 0. You have to balance it. So add a positron. Here. E positive means positron. Now, why do we call it beta plus decay? Because we say in this decay, a positron is released, a positron is emitted. You see the reaction. Sir, why we are emitting the positron here? Because so that the reaction remains balanced. Sir, why do we call it the beta minus decay? Because an electron is released here. Why? So that the reaction remains balanced. Okay. In terms of nuclei, how do we write it? X. A is the mass number, Z is the atomic number. Sir, we say neutron is converted to the proton. Okay. Or sorry, proton is converted to the neutron. Now, mass number remains same, atomic number decreases by 1. So can I say here, A remains same, Z decreases by 1. Okay, guys, please tell me in the chats if this is crystalline clear. In case of beta minus decay, atomic number remains the same. We say, sorry, mass number remains the same, atomic number increases by 1. In case of beta plus decay, mass number remains the same, atomic number decreases by 1. In case of beta minus decay, electron is released. In case of beta plus decay, positron is released. That's it. Alpha decay. When it comes to this particle, this has got large number of protons, large number of neutrons. So in order to reach stability curve, it will have to lose protons as well as neutrons. So it will lose 2 protons, it will lose 2 neutrons. So in one alpha plus decay, 2 protons, 2 neutrons are released. Okay. Now, see, guys. We say when it comes to the 2 protons, when it comes to the 2 neutrons, when they join together, they forms the alpha particle. So alpha particle consists of 2 protons and 2 neutrons. That's why we call it alpha decay, because here alpha particle is released. Now see, we say you have got the X nuclei. Mass number is A, atomic number is Z. It is converted to the Y nucleus. Now tell me, if 2 protons minus 2p minus 2 neutrons, total of how many particles? So total of 4 particles have been decreased. So A minus 4. And total of how much charge has been decreased? Sir, Z is equal to 2. Why? Because 2 protons means 2 positive charge. So Z minus 2. Now I say in alpha decay, here A decreases by 4. In one alpha decay, mass number decreases by 4 and atomic number Z decreases by 2. Okay, and mass number and atomic number Z decreases by 2. And then we write over here 2He4. What is 2He4? This is called alpha particle. 2He4. 4 means mass number, 2 means atomic number. That's what I said. 2 means 2 positive charge. 4 means 2 protons plus 2 neutrons. Is this clear? So, sir, what is important in this? In alpha decay, mass number is decreased by 4, atomic number is decreased by 2. Sir, in beta plus decay, mass number remains the same, atomic number decreases by 1. In beta minus decay, we say mass number remains the same, atomic number increases by 1. Okay. Okay. Give me the signal in the chats if this is clear. Give me the signal in the chats if this is clear, guys. And smash the like button if you are not like this session yet. Okay. Now tell me the answer of first question. Now you would be able to solve all the questions. 100% guaranteed. Now tell me. See, a deuteron means 1H2. Deuteron means 1H2. Mass number is 2, atomic number is 1. 1 proton, 1 neutron. Okay. This is a simple thing. Whenever you see 1H2, what does it mean? It means particles are 2. Only one charge, one particle has charge. So obviously it is neutron and proton. Is bombarded on 8O16 plus 8O16. This is how we write it. This is bombarded. This is added with this. You can write it like this. Then alpha particle is emitted. 2H, or you can write it like this, 2 alpha 4. Alpha particle is released. Okay. And the product nuclei plus, let's suppose product nuclei is anything like Y. Okay. The product nucleus is, you have to say, or if it is, okay, Y. We don't know which one it is. Let's consider Y. Guys, in this nuclear reaction, always remember, balance the mass number. Mass number remains the same. So balance the mass number. See, 16 plus 2 is 18. From this side also, it must be 18. So 4 is already there. So 4, it must be 14 over here. So 14 plus 4 is 18. Now check in which of the option we say mass number is 14. So option D. Option D. As simple as that. So balance the mass number. Tell me this one. Tell me about this one. The nucleus 48CD115. After emission of 2 successive beta minus particles. Okay. Okay. So it is losing. Okay. After the 2 successive of beta minus particles. So means beta minus decay has happened. So beta minus decay has happened. So after 2 beta minus decay. Guys, tell me one thing. When a beta minus decay happens to a particle, mass number remains the same. Atomic number, what happens to the atomic number? Beta minus. We say mass number remains the same. Atomic number increases by 1. So if 2 beta minus decay has happened, we say mass number remains the same. Atomic number must be increased by 2. We say here Z must increase by 2. So final result must be CD115. This should remain the same. Atomic number must be increased by 2. Here it should be 50. Yes. Yes. What about this one? This is important. This is important. Now tell me, what is the respective number of alpha and beta particles, means alpha and beta decay, emitted in the following radioactive decay? Guys, see. 90 x 200. Okay, it is converted to 80 y 168. So basically there is a nucleus. X nucleus is converted to this Y nucleus. You have to see how many number of alpha and beta decay has taken place. Tell me one thing. Guys. What about mass number? Mass number has changed. In beta minus and beta plus, mass number remains the same. Okay, yes. So mass number only decreases in which? In alpha decay. Now tell me. I'll write 200 minus 168, that is 32. Mass number has been decreased by 32. Now, in one alpha decay, mass number decreases by 4 times. So if I say 32 divided by 4, that is 8. So how many? We say 8 alpha decay have taken place. So if mass number has decreased by 32, so in one alpha decay, mass number decreases by 4. So 32 divided by 4 means 8 alpha decay have taken place. Yes. Now, if 8 alpha decay has taken place, in one alpha decay, atomic number decreases by 2. We say in 8 alpha decay, we say Z decreases by 16, because in one alpha decay, atomic number decreases by 2. In 8, atomic number decreases by 16. Now tell me. We say, so 90 minus 16 is equal to how much? That is 74. 90 minus 16 is 74. So here it must be 74, but it is 80. But here it is 80. So so if we say we say 6 has been added. So now tell me, in beta minus or beta plus, I guess in beta minus decay, atomic number increases by 1. So 74 plus 6 beta minus decay has taken place. If 6 beta minus decay has taken place, so we say 74 plus 6. So 74 plus 6 is equal to 80. That's why you are seeing 80 over here. And when it comes to the mass number remains the same. So can I say in nutshell, my dear friends, we say in this radioactive decay, how many alpha decay has taken place? 8. How many beta minus decay has taken place? 6. So 8 alpha decay, say 6 beta minus decay. 8 and 6, option B. I hope this is crystalline clear. Okay. So guys, I hope you have joined my Telegram channel, okay? Join this Telegram channel. It's extremely important because I'll be sharing all the notes, everything over there only. Okay. So here is the Telegram channel link. Okay. So that is all for today. See you guys in the next session. We have some topics pending, okay? See you guys in the next session. Thank you so much. Thank you for today. I hope you like this particular session. Do let me know in the comments how was the session. Did you like it or not? Okay, do you want more sessions like this? Do you want me to complete all those 25 topics? Do let me know in the comment section. Okay, once I end the live stream. So take care and bye-bye. See you guys. Yes. See you guys very soon. Thank you so much. Thank you.